If you've ever dealt with infrastructure as code, you've probably felt that frustration. You need a scalpel for a tiny specific job, but all you've got is a sledgehammer. Well, today, we're going to talk about how to get that surgical precision, generating code for exactly what you need and nothing you don't.
So let's paint a picture. It's a classic situation, right? You just need to replicate a single VPC for a new environment. But what happens? Your export tool goes and generates Terraform for the entire AWS region. It's the definition of overkill, and honestly, we can do better. And that leads us right into what I call the infrastructure overload problem. It's this super common challenge where the tools we use are built for these massive, broad strokes, but they just don't have the finesse we need for those targeted everyday tasks. Think about it like this. On one hand, you've got that all-or-nothing approach. It just buries you in this massive, bloated script full of dependencies you don't even need. But on the other hand, you've got the ideal, a clean, focused script with only the resources you care about. And look, the difference isn't just about convenience. It's about being efficient and seriously cutting down the risk of human error. Because what's the result of that bloated script? It's always the same thing, isn't it? You end up spending hours, maybe even days, just manually deleting code, trying to untangle all these dependencies, and cleaning up a file that's like 90% irrelevant to your job. It's just a huge waste of valuable engineering time.
And this quote really just hits the nail on the head. Sometimes you need Terraform only for specific resources, without exporting the entire region. It's so simple, but it perfectly captures the core of the problem so many of us face.
Okay, but what if we could just move past all that frustration? Well, that's where this idea of surgical precision comes in. We're talking about a whole new way of getting absolute, fine-grained control over your infrastructure as code.
And this brings us to a really key concept: resource-level IAC generation. All this really means is having the power to generate clean Terraform for the individual resources you pick, not the entire environment they just happen to be sitting in. And a tool like Cloudshot is what makes this a reality.
So this approach, it's not just precise. It's also fast, it's visual, and most importantly, it puts you in complete control. That combination of speed and accuracy, that is a total game changer for any DevOps or platform engineering team trying to move faster and, safer. So, you're probably wondering, how does this actually work in the real world? Great question. Let's walk through the super simple 4-step workflow that makes it all happen. First things first, you need to actually see what you're working with. So a tool like Cloudshot goes out and discovers all your key AWS resources. We're talking VPCs, subnets, EC2 instances, route tables, you name it, and gives you this complete interactive visual map to work from. And once you have that visual map, the whole process is incredibly straightforward. Step 1, you discover your infrastructure. Step 2, you visually select the exact resources you need. Step 3, make a couple of quick configurations. And Step 4, you download your script. That's it. Now here's a really clever, time-saving little detail. When you select something big, like a VPC, all of its child resources are automatically included by default. So your job isn't to hunt around and add every little thing, it's just to uncheck the few things you don't want. It's a subtractive process, which is so much faster. And in that final configuration step, you get some really powerful options. For example, you can instantly target a completely different region for replication. Or you can apply your team's naming conventions, adding a prod prefix or an app suffix to make sure the code you get fits right in with your existing standards. Okay, so you've got the script. You downloaded the file. What's next? Well, this is where the rubber meets the road, where you go from a generated file to actual live running infrastructure. And the key thing to remember here is that the file you download, it's not some rough draft or a starting point. No, this is a clean, production-ready Terraform script, scoped exactly to what you asked for, and it's ready for deployment right away. And because it's just standard, high-quality Terraform, putting it to work is as simple as running the commands you already use every single day: init, plan, and apply. It just slots right into your existing CI/CD pipelines. There's no learning curve. This is the real before and after moment. We've gone from all those hours of manual code cleanup to this. 0 manual filtering and 0 guesswork. You get exactly what you asked for every single time. And yeah, the time saved is huge, but the reduction in potential errors, that's even more valuable. A capability like this unlocks so many powerful use cases. I mean, imagine being able to audit your firewall rules by exporting just your security groups.
or creating version-controlled backups of your most critical network pieces. You could even use this to generate the foundational code for a massive cloud migration, saving weeks of manual work.
So really, it all boils down to this final thought from the source material. This is how Cloudshot gives you precision control over infrastructure as code. It's about so much more than just generating a script. It's about giving you that fine-grained surgical control over your entire cloud environment.
Thanks, John. I'll kick off the demo now. Let's jump into Cloudshot and see it live. Start by running a network discovery on your cloud account, just as you normally would. To begin, click on AWS Network Discovery. Choose your current infrastructure region, in my case, is in California. And then click Show Deployment. Cloudshot will automatically scan your cloud environment and generate a complete visual diagram of your existing AWS infrastructure. Once the discovery is complete, locate the VPC you want to work with. Now, select the VPC, click the More Options icon, and then choose Generate Terraform Script. This opens the Terraform region replication pop-up, but this time, it's scoped only to the selected VPC. Under the VPC, you'll see all associated resources automatically listed. By default, everything is selected. If there are resources you don't want in your Terraform script, simply deselect them. I will deselect 1EC2. No manual code cleanup required. Next, choose your target region. In this example, I'm keeping the same region since I want Terraform for backup, auditing, or version control, not cross-region replication. You can also apply naming conventions, such as prefix or suffix. These will automatically update all resource names inside the generated Terraform files. Once your selections are complete, click Download Terraform. Cloudshot instantly generates a clean, production-ready Terraform script, scoped exactly to the resources you selected. Once the file has been downloaded, open it in your terminal and run the following commands. Before running the Terraform commands, ensure that you have configured your AWS credentials in the script. Terraform init initializes the Terraform working directory by downloading required providers and setting up the backend. Terraform plan generates and displays an execution plan, showing the changes Terraform will make to your infrastructure. Terraform apply executes the plan changes to create, modify, or delete infrastructure as defined in your Terraform configuration. You've now generated Terraform only for the VPC and resources you need, with zero manual filtering and zero guesswork. Finally, return to Cloudshot and run network discovery for same regions again. This is how Cloudshot gives you precision control over infrastructure as code, whether you're exporting, auditing, or preparing for migration. The VPC has now been replicated without the deselect EC2, and that's how easy it is to replicate your selective infrastructure. Thank you for watching.